Okay, hi. Today we're going to talk about, this is lesson 8.2, how to identify an oxidation reduction reaction. Now, an oxidation reduction reaction is simply when one element loses electrons and one element gains electrons. So oxidation is when an object loses electrons. And you can think about it like this. Leo the lion says grr. Loss of electrons is oxidation, gain of electrons is reduction. So what you have to do first, there's a couple of steps. If I were to ask you whether these are oxidation reduction reactions, yes or no, this is how you determine. So, first things first, you're going to identify the oxidation numbers of every element present. Now, most of these are going to be pretty easy, because the first thing you want to do is you want to follow my 3 rules that I told you about in the last video. You want to find out whether it is an element, whether it is group 1, or whether it is oxygen. We always know those, group 1 or group 2, sorry. So anything that's an element, first of all, is going to get an oxidation state of 0. So as I look up here, this is a compound, this is a compound, this is a compound, this is a compound. Nothing 0. This is one of the Hofbrinkels. Remember Hofbrinkel, diatomic. Oxidation state, 0. I'm just going to write it up here for my own use. Oxygen, also Hofbrinkel. Oxidation, 0. Nitrogen dioxide, compound. We're not going to do that yet. Zinc, element, 0. Copper sulfate, compound, not yet. Zinc sulfate, not yet. Copper, element, 0. We've done all those now. Now I'm going to go on and do the next easy ones. I'm going to do the group 1 and the group 2. Okay? Magnesium, group 2. This is +2. Sodium, group 1. That's +1. Magnesium, group 2, +2. Sodium, group 1. +1. Down here, I can't do anything there. These are not. So I'm going to skip that. I'm going to go on to the next thing I know for sure. Anything that's oxygen is getting a -2. Sorry, if it's an oxygen in a compound. Oxygen, -2. Oxygen in a compound, -2. Oxygen in a compound, -2. Now, I'm going to tell you a little trick about these two. Sit down for this. You notice, sulfate is here, sulfate is here. I'm not going to do anything with it yet, because this is a table E, and it doesn't change identities. So if it is a polyatomic ion from table E, you don't have to do it. You don't have to identify the individual elements. You look at your periodic table, and chlorine has a whole bunch of oxidation states. However, if there's 2 of them, this is +2, this has to be -2. Each one is -1. Again, over here with sodium chloride, +1, chlorine has to be -1. Now, over here, this oxygen is -2. However, there's 2 oxygens, and each one is -2. So this nitrogen has to be +4. And now that I think about this, nitrogen, you're going to notice, has probably the most, actually it does have the most oxidation states of any element on the periodic table. And +4 is one of them. Now going on to the bottom, copper has 2 possibilities. Could be either +1 or +2, and zinc only has 1 possibility, and it is +2. Now, how do we determine which one this is? Copper 1 or copper 2? I don't want to figure this whole thing out. And let's just treat this sulfate as 1 item. Or let's just treat it like it's 1 element. I'm going to look at table E. Table E, which has all the polyatomic ions. If I look at the charge of sulfate, SO4, it's 2-, -2 charge. Again, 2-. This is a -2, this is a +2. Again, plus 2, minus 2. They both have to equal 0. So since this is minus 2, this has to be plus 2. Okay? That is the first step. Identifying the oxidation states of everything that is present in the reaction. Now we're going to look and figure out if something is being oxidized or if something is being reduced, or if there's no change at all. So if there's no change, nothing is happening. If something is being oxidized, like I said, it is losing an electron. When you lose an electron, like a metal, it loses electrons, it becomes positive. So you're looking for the charge to increase. Charges increase, becomes more positive. So reduction, the charge decreases. So pay attention while you're looking through these. Now as we look at this, magnesium, plus 2, plus 2. Nothing happens. Get in the habit of crossing it out. Sodium, plus 1, plus 1. Again, nothing happens. Cross it out. Chlorine, negative 1, negative 1. Nothing happens. Cross it out. Oxygen, negative 2, negative 2. Nothing happens. Cross it out. So this first reaction is not an oxidation-reduction reaction because nothing is neither oxidized nor reduced. When we look at the next one, nitrogen goes from a 0 to a plus 4. Nitrogen is oxidized. Oxidized, 0 plus 4, that is an increase in charge, that is oxidation. If you look at oxygen, 0, negative 2, oxygen is reduced. Now let's look at the bottom one. Again, SO4, SO4, guess what? No change, cross it out. In fact, if you have a polyatomic ion on the left and a polyatomic ion on the right, it's not going to change as long as it's SO4 here, SO4 here. When I look at this zinc, zinc, 0 plus 2, this is oxidized. Copper, plus 2 goes to 0. This is reduced. So, we have 2 oxidation-reduction reactions. Now, that seems like a lot of work, doesn't it? Let me show you a shortcut. Okay. Element, compound. Element, compound. If you have something that's an element, like this is a single replacement reaction. If you have something that's an element here, and it's a compound over here, and then there's something that's a compound here, but it's an element over here, that's an oxidation-reduction reaction. That's your shortcut. But it's never a bad idea to verify because you never know when the Regents is going to throw a tricky one in there. I'm going to have a lot of practice problems on this. I'm going to give you guys a simple one right now to tell me what is oxidized and what is reduced. Boop, 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 boop. Enjoy.